So in this video, we're going to be taking a look at the composition of cartilage. So we're going to first look at the different types of cartilage, and we're going to take a look at hyaline cartilage, then elastic cartilage, and finally fibrocartilage. For each of these subtypes, we'll go over their composition and their function, as well as their location. So let's start with hyaline cartilage. Hyaline cartilage is what forms the model for the developing fetal skeleton. It's also the most common type of cartilage. It's located within the nasal septum, the larynx, the trachea, the bronchi, articular surfaces, and ventral ends of the ribs. This type of cartilage contains mostly proteoglycan aggregates, and the rest of the matrix is formed by type 2 collagen. Proteoglycan aggregates, if you remember, are composed mostly of water, which allows cartilage to be very flexible. Hyaline cartilage also provides strength and has a high resistance to pressure, and all of this is due to the high concentration of water. So water makes up about 60 to 90% of hyaline cartilage. So this is a slide of some chondrocytes located within their lacunae, which are mostly isogenous groups of about 2 or more chondrocytes with their lacunae. As you can see here, there aren't any visible fibers of collagen within the matrix, which is that purpley color. Instead, it's a homologous mix of type 2 collagen and proteoglycan aggregates. So next, we're going to take a look at elastic cartilage. Elastic cartilage, as its name gives away, contains a large portion of elastic fibers, which interweave with type 2 collagen to form a dense matrix. Elastic cartilage is located within the external ear, the auditory and eustachian tubes, as well as the epiglottis and the larynx. Elastic cartilage function is to provide that extra flexibility due to the elastic fibers woven into its matrix, and this allows for the cartilage to stretch, bend, and bounce back more readily than the other types of cartilage. So taking a look at elastic cartilage, this picture is a slide dyed with Verhoff stain used for especially to stain elastic fibers. So the elastic fibers will stain black for this. As you can see, all the black areas and black fibers within this slide is the elastic, which consists the majority of the matrix. Next, we're going to take a look at fibrocartilage. Fibrocartilage is located within ligaments and tendons because it's used for strength as well as ability to bear stress without easily tearing. Because of this, fibrocartilage does not allow for a rigid support. Fibrocartilage is the only type of cartilage that does not have a perichondrium surrounding it. It's composed mostly of type 1 collagen, which is also different than the other two types. And this type 1 collagen fibers are arranged into bundles, and the bundles run oriented parallel to each other. This parallel arrangement is the reason why fibrocartilage is not rigid, but it is very strong in terms of stress bearing and strength. Fibrocartilage also contains a low volume of water and proteoglycan aggregates, which is also different from the other two types. So taking a look at this slide of fibrocartilage, you can see here the parallel bundles of type 1 collagen, which is the pink colors along here, also inserting right here and weaving their way down into this muscle right here. So in the far right is the muscle and the bone is on the far left. So that means we are taking a look at a tendon. So this slide is taken from a pubic symphysis. This slide is also a good example of showing how fibrocartilage does not use or need a perichondrium. As you can see, there's nothing surrounding it, there's nothing outlining it, it's just inserting directly into the bone and into the muscle. So first we took a look at the hyaline cartilage, which is the most common type of cartilage. We next moved to the elastic cartilage, which is useful for support and flexibility. And then we talked about fibrocartilage, which lacks a perichondrium and is composed mostly of type 1 collagen.